So hi everyone, I welcome you all to the second lecture of Chemical Engineering Thermodynamics course of NPTEL. My name is Varad Dav. I'm a doctoral student at the Department of Chemical Engineering, IIT Kanpur, and today we'll be starting with we'll be solving some sample question which will help you which will prepare you for solving the week two assignment problems, right? So we'll wait for a couple of minutes for other people to join in, and then we will start. So we'll wait for a couple of minutes for other people to join. Let us start with the first question. The first question is a relatively easy question. The sublimation of pure water can occur at which of the following options is correct? A, only at triple point. Option B, above the triple point. above the triple point. Option C, in between critical point and triple point. Between critical point and triple point. And option D, above the critical point. So anybody has any question? Is straightforward. Anybody has any answer? Anybody would like to attempt? So for this you must know what is critical point and what is triple point. What is critical point? So critical point is the highest point in which liquid and gas can coexist, whereas triple point is the point in which all the three phases, solid, liquid, and gases, can coexist. Right. For example, if you draw the PV diagram of pure component, this is origin, this is pressure, and this is temperature. This is in degree Kelvin, and this is in ATM. So the PV diagram for water looks like this. So we have like this, and then this will be the, so this part, this is point O0, this is point A, this is, let's say for example, point C, this is point C, so this is point C, this is point B, this is point E, and for example, this is point D. So for pure water, this temperature TC, sorry PC, right? This is TC. This is TC, right? And this part is called as sublimation curve. This is the sublimation curve, right? This is the vapor liquid equilibrium line, and this is the solid liquid solid vapor equilibrium line, right? So this point is called as triple point, whereas this point is called as critical point, right? In this phase it is solid, here it is liquid, and here it is vapor. It's a clearly what our question is, sublimation, right? Sublimation means solid to liquid, solid to gas conversion, or solid to vapor conversion, right? The solid to vapor conversion will occur in this region, right? So clearly only, sorry, sublimation is solid to liquid, right? So the correct answer is option A, right? Only below triple point, right? From here, sorry, this is liquid, this is solid, this is liquid, right? So sublimation will occur only this. That means the pressure and temperature has to be below the critical point, right? So answer is option A, that is only below the triple point, right? The sublimation can be carried out below the triple point only. Above it, the ice will first liquefy and then evaporate, right? So anybody has any doubt? nobody has any doubt, then we'll move on to the next question.
Can you show this graph again? I have one doubt here.
Yes. Yes.
This line A, C,
1
E
minute.
below this should
Yes.
be this should be vapor, right?
Where?
Line A, C, E below this. Below area
It should
should
be,
be
no. Below this, it should be what you're saying?
below should be vapor.
No.
Vapor.
Above will be vapor, right? Because
No,
this part is going to be supercritical, right?
right.
So this has to be vapor, right? This will be vapor and this will be that.
What I'm saying is when pressure, you reduce the pressure, we go to the vapor phase. So you are increasing pressure and showing the vapor. So there it is, right?
Let me just confirm it. Just 1 minute. Oh, I think this is not PV diagram. This is TV diagram.
Okay.
Three-phase diagram, yes. Sorry. This is not PV diagram. This is, I think, TV diagram. Let me just check. Oh, this is PT diagram. This is pressure, right? And this is temperature. That's why it's critical pressure, and this is critical temperature, right?
No, that's a way. Which area will be vapor? Which area
So
will be?
So this will be vapor. This part will be vapor.
No,
right?
when you are increasing pressure.
We are increasing temperature, yes.
When we are increasing for given pressure, given temperature, when you increase pressure. So
given temperature, yes.
When you increase, yeah. So it is likely to change in liquid phase, right?
It is likely to change into liquid phases. That is, but maybe it is because if you start from point which is below triple point, and then we go, then we see that thing.
True. In the triple, I'm talking about only triple below critical point only. So let us take one condition like point C. You are below point C for given temperature. For that temperature, if you start raising temperature.
Yes.
So what we are expected? We are expecting that it will turn to liquid phase.
Yes.
Right, no?
You are correct. Yes, you are correct. So this has to be, I think, this is wrong. This has to be vapor phase, right? This has to be vapor. This has to be liquid, and then this will be a solid.
Right. So what question is, suppose we have to the area O to A. This region, this sublimation can happen. Yes. So the answer is, the options are given. Yes. The options are not like that. No, it's writing like only at a triple point.
It has to be below. It has to be below, right?
It has to be below the triple point, right?
Yes, this has to be below the triple point.
But the option is not there, right?
Yes. It has to be below the triple point. Yes, you are correct. It has to be only below. Says I wrote like this, but maybe I had a typo in here.
Okay.
Only at below the triple point. Okay. So we'll move on to the next question.
Okay.
Question 2. The question 2 which we have is the pressure gauge. The pressure gauge on a 1.5 meter cube oxygen tank reads 500 kilopascal, and we are asked what is the amount of oxygen in the tank if the temperature is 30 degrees centigrade and the atmospheric pressure is 101 kPa. What we have to assume is oxygen as an ideal gas. Right? And the options are 9.53 kg, option B 19.08 kg, option C 115.67 kg, and option D 11.45 kg. Right? So I'll give you a couple of minutes to solve it. Simply just have to use ideal gas equation to get the answer.
Can you please show the question? I'm not
Yes,
seeing.
yes. So remember that here is pressure gauge. Right? That means it's a gauge pressure. So anybody has answer? Anybody would like to give an answer? Okay, then let me start. So what we are given is, let us first understand the question. So what we have, the pressure gauge on a 1.5 meter cube oxygen tank. So what we have is, we have a tank which is filled with oxygen, right? O2, and its volume is going to be 1.5 meter cube, right? And pressure gauge to this, a pressure gauge is attached, and it is reading gauge pressure of 500 kilopascal, right? So what we have to find is, and its temperature is also been given as 30 degrees centigrade. What we are asked to find is, we are asked to, and atmospheric pressure is also given. PATM is given as 101 kPa, and we are asked to find what is the number of moles or what is the amount of oxygen atom, oxygen gas which is present inside this tank. And we are asked to assume that we can treat that oxygen as an ideal gas. So the first thing which pops up to our mind whenever we say ideal gas is ideal gas equation. Just PV is equals to nRT, right? So this is number one equation. We are already given V as 1.5 meter cube. But in this expression, the pressure which we want is P absolute, right? What is the relationship between absolute pressure and Gauss pressure? So it's right. P is equals to P absolute is nothing but P gauge plus P atmosphere, right? What is the Gauss pressure we are given? We are given 500 kPa, right? It's 500 kPa plus 101 kPa, 101 kPa, which amounts to P absolute as 601 kPa, right? So we put in the values. So P is nothing but so when we use appropriate value of R, we can convert this from number of moles to mass of, right? Number of moles to mass. In that case, what's it going to be? So let us first write this down. That N is nothing but PV by RT. So depending on the value of R, we get either N or we get either M. So let us write PV is equals to where M denotes the mass of the gas, right? Let's say for example R1 by T. You can just convert from R to R1 using the depending on the mass of the gas, right? So it turns out that R1 for oxygen gas corresponds to about 0.2598 in SI units. This you can find in any standard thermodynamics textbooks, right? So M is nothing but 601 kPa multiplied by what is the volume? 1.5 meter cube divided by R value, which is 0.2598 Pascal meter cube kg Kelvin multiplied by temperature. What is temperature? Temperature is given as 30 degrees centigrade. That means temperature is 30 plus 273, which corresponds to 313 Kelvin. Right? Multiplied by 313 Kelvin. Amounts to M is equals to 11.45 kg, which is option D. Right? I hope the solution is clear to everyone. If you have any doubt, you can ask. Otherwise, we'll move on to the next question.
Sir, can I record this meeting?
Can I record? So this meeting is going to be recorded and it's going to be uploaded onto the portal under week 2. I think the last session should have also been uploaded. If not, then I will ask the members to upload it. But this is remain assured that this is going to get uploaded onto the portal. Okay. So we'll move on to the next question. Question number 3. So what we have is we have a carbon dioxide contained. Carbon dioxide gas is contained. In a piston cylinder arrangement. Piston cylinder device. And this gas is compressed from 0.3 meter cube to 0.1 meter cube, and during this process the pressure and volume pressure and volume are related by E is equals to AV to the power minus 2, right? Where value of A has been given as 8 kilopascal meter to the power 6, and what we are asked to find is calculate the work done on the carbon dioxide gas during this process. And the options are 46.8 kilojoule. Option B is 41.9 kilojoule. Option C is 53.3 kilojoule. And option D is 59.6 kilojoule. Next. So I will give you a couple of minutes to solve it. So the hint is, let me give you a hint. You can use the definition of work. What is the definition of work? Is nothing but integral PDV. Depending on which sign convention you use, you can write plus or minus, right? For example, delta W is going to be integral PDV, where volume changes from initial value to final value. Right? And here, if you look at it carefully, you are already asked what is the work done. That means the sign is already inherent in the work. So what you need to find is, you just need to find the absolute value. So I'll give you 5 minutes to solve it. So anybody has solved the question? Anybody has answer? I'll wait for more time sometime. Sorry. This is the question. Just put this hint number 2 is just substitute the value of P in here. The correct answer is option C. Did anybody get it? So delta W mod of is nothing but integral PdV from V is equals to V1 to V is equals to V2, right? What are we given? We are given P as A by V square, right? Therefore, it's going to be V is equals to V1 to V is equals to V2, A by V square dV, right? The integration comes out to be A 1 by V2 minus 1 by V1, right? So when you put in the value, delta V is nothing going to be the mod of this thing, right? It's nothing but mod of this. So what is A? A has been given as A kilopascal meter to the power 6 into 1 by 0.1 minus 1 by 0.3, 1 by meter cube, and this whole under mod cell, right? That's why delta W is nothing but mod of delta W is nothing but minus 53.3 kilojoule, which corresponds to 53.3 kilojoule. And this is the answer. Is equal to work done. Nothing but 53.3 kilojoule. So you can write down if you would like. I'll give you a couple of minutes. Then we'll move on to the next question. So the next question, and nobody has any doubt, right? Anybody, if anybody has any doubt, they can ask. Otherwise, we'll move on to the next question. And the next question is question number 4. Read it time. Volume is given. Is divided into 2 parts by partition. Is divided into 2 parts by a partition. And on one side, inside of the tank contains ideal gas at 500 degrees centigrade, whereas the other side is evacuated and has a volume size of the part containing gas. Partition is now removed. Is now removed, and the gas expands to fill the entire tank. And it is now applied. It is now applied to the gas until pressure equals initial case. And we are asked to determine the final temperature of the gas. Given 500 degrees centigrade, 2327 degrees centigrade, 2819 degrees centigrade, and option D, insufficient information. So let us first understand what is the question. Then we can try. So what we have is, we have a rigid tank. That means the total volume. Rigid tank means total volume is going to remain constant. Right? Then what we have, whose volume is unknown. So let's say total volume is going to be Vt. Vt is equals to, or for example, like total volume is equals to Vt is unknown, and it is divided into two parts. So let's take an example. This is the total container, and it is divided into two parts such that one side of a tank contains ideal gas. This contains a gas which is at temperature 500 degrees centigrade, and let's say for example T1 volume is V1, and this volume is going to be 3 times V1, right? The other side is evacuated and has a volume of thrice the size of the part containing gas, right? That means total volume is going to be V1 plus 3V1 is 4V1, right? And the partition, so this is the initial system. Now what is going to happen is, this partition we are going to remove. So it's going to be a total system, full gas, a full container which has a gas and with a volume of, let's say for example, V2 is equals to, or Vf equal to, this is EF, which is equals to 4V1, right? And what we are asked to find is, we are asked to find what is the temperature of this gas. Let's say for example Tf, right? Naturally, you can use, though it is not mentioned in the question, it is always good to assume that it is an ideal gas. Assume ideal gas. Assume ideal gas behavior. So now maybe you will be able to solve this question. Remember that the work of expansion here is going to be 0, right? Because here we have pressure equal to 0 because it's evacuated, right? It's going to be evacuated. Is evacuated, right? So there is no external force which opposes the expansion of this gas, and hence the work done by this gas would be 0 in this case. And you also you can also assume ideal gas behavior. I think the question is now attemptable. I've given the basic premise of the question. Now you can try to solve the question. I will give you a couple of minutes. Anybody has any doubt in understanding the question? Anybody is able to get the answer? Remember to convert from degree centigrade to Kelvin. Always try, remember to convert this 500 degree centigrade to this temperature Kelvin. Always assume SI units. Anybody would like to share the answer?
Is it 2819?
It is 2819. Yes, that is correct. The correct answer is 2819. So, for those who could not solve, let us try solving it. So let us say that the subscript 1 denotes initial state and subscript 2 denotes final state. Initial state, that means this state, and 2 is final state. That means this state, right? This is 2, this is 1. Right? What we have is V2, which is final volume, is going to be nothing but this volume plus this volume, which is V1 plus 3V1, right? Which implies V2 is going to be 4V1, right? And the mass, as the system is closed system, the mass of the system is going to remain the same, right? That means M1 is going to be also equal to M2. And we are also given that it's an ideal gas, right? Here you see it's an ideal gas. So we just write P1 V1 by T1. It's nothing but P2 V2 by T2, right? So we substitute the value P1 into V1 by T1 is going to be P2 into 4 times of V1 by T2. Right? And we also know that the pressure of the system is going to remain same because initially the pressure was 0 here, right? So this is the final pressure, right? And this is the initial pressure. So what we have is PV by T, PV by T, P1 V1 by T1 is going to be nothing but P2 into 4 times V1 by T1, right? So which corresponds to T is going to get cancelled, V1 by T, and V is also going to get cancelled. So what we have is 1 by T1 is going to be 4 by, here it has to be T2. Implies T2 is nothing but 4 times T1. And what is T1? T1 was given as 500 degrees centigrade, which is 500 plus 273, which is 773 Kelvin. Therefore, T2 is going to be 4 times 773, which corresponds to T2 is equals to 3092 Kelvin. Right? And hence T2 is going to be 3092 minus 273, which is 2819 degrees centigrade. Therefore, final temperature is 2819 degrees centigrade. That is option C, I think. Option C. Anybody has any doubt? They can 1 minute. So anybody has any doubt in that question? Else we'll move on to the next question. Again, a similar question we'll do the next question, which will be question number 5. Okay. So what we have is argon in the amount of 1.5 kg fills a 0.04 meter cube piston cylinder device at 570 kPa. The piston is now moved by changing the weights until the volume is thrice the original size. During this process, argon's temperature is maintained constant. In the previous case, the temperature was going to vary, but the pressure was remaining constant. Whereas in present case, the temperature is going to remain constant, right? Determine the final pressure. Determine the final pressure in the device. So again, you have to assume argon as an ideal gas. Ideal gas. These are 167.67 kPa. Option B is 250 kPa. Option C is 190 kPa. And option D is insufficient information. So what we have is again argon in the amount of fills the. So for example, we have like this a piston cylinder arrangement, right? And certain weights are put in here. So what we have is this gas is filled with argon, and the mass of argon which is inside this gas, which is inside this device is 1.5 kg, and initial volume is 0.04 meter cube, right? And initial pressure is also given as 570 kPa. Now these weights are going to be removed slowly, right, until final volume. So this is initial state, and after some time this is going to be like this. Some pure weight, right? Again argon is going to there, so the mass is again going to remain the same, but now the volume V2 is going to be thrice of V1, right? And the temperature is going to remain the same. Let's say here temperature was T1, here T2 is going to remain the same. Now we are asked what is the final pressure. Assuming that this is final state, assuming that we have an argon gas, we can assume argon gas as an ideal gas. Right? So the solution is very similar to the previous problem. I think everybody should be able to solve this question. So I'll give you 5 minutes to solve it. Anybody able to solve it? In the next set of examples, we are going to need steam tables. Okay. So anybody able to get the answer?
So option C, 190 kPa. It is a correct.
Hello, can you guys hear me?
Yes, yes.
So the answer, somebody has answered.
190 kPa.
Yes, the answer is correct. 190 kPa. The answer is 190 kPa. This is correct one. Everybody got it? Just for those people who did not get it, I'll explain. So again, let us assume that initial state is denoted by 1 and final system is denoted by 2. So clearly we have P1 V1 by T1 is going to be equals to P2 V2 by T2, but temperature is the same, right? Hence we can neglect this. P1 V1 is equals to P2 multiplied by what is V2? V2 is 3 times V1. Right? This implies P2 is nothing but P1 by 3. And what is P1? 570 kPa, right? 570 divided by 3, which corresponds to 190 kPa. This is option C. Okay. We'll move on to the next question. It's a match the pair type of question related to the first question. So what we have to do is I am going to give list 1 and list 2. For example, like this. Question number, this is the question number 6. So it's going to be like this. I'm going to give list 1 and list 2, and you have to match. So the first option here is critical point. Second option is sublimation. Option C is triple point. And third one is melting. Now you have to choose one from this list 2, which corresponds to which. So here we have list 2, and here we are going to have list 2. All the phases, that is solid, liquid, and gas, coexist in equilibrium. Coexist in equilibrium. The second is phase changes from solid to liquid. Phase changes from solid to liquid. Properties of saturated liquid. Properties of saturated liquids and saturated vapor are identical. are identical. And the fourth one is heating process. Where the solid gets directly transformed to gaseous phase. And the option for this are option A, A2, C1, C4, D3. Option B is A3, C4, C1, D2. Option C is A2, C4, C1, D3. And option D is A3, B1, C4, and D2. What you have to do, you have to match the pair. Like for example, which of the following in these two is accurate for critical point, whether it's this one or this one or this one or this one. Similarly, what is the which of the pair of these two is true for this sublimation, so on and so forth. And these are the options for them. Right. So this should be apparent. What is critical point and sublimation and triple point? This should be apparent from discussion of our first question. Right? So I'll give you a couple of minutes to solve it. So anybody got any answer? Any straightforward question. So anybody has any answer? So clearly, let us start with what is melting. Melting is nothing but conversion from solid to liquid, right? So clearly, D corresponds to option 2, right? Then critical point. So what is critical point? So if you looked at that graph, you see that at critical point, we have that there is no distinction between liquid and solid, liquid and vapor, right? Or for example, let's first consider triple point. So triple point is nothing but, as the name suggests, it's a coexistence of 3 points, 3 phases, right? So clearly, C is also going to be 1. All the 3 phases are going to be in equilibrium, right? So that means this eliminates this one, eliminates this one, right? This eliminates this one also. So just by process of elimination also, you can find the answer. What is sublimation? Sublimation is direct conversion from solid to gas, right? That means option 2. So B is 2, right? Sorry, B is 4. Right? Direct, where solid gets directly transferred to gaseous phase. B is 4 and A is 3. Right? Properties of saturated liquid and vapor are identical. Just by the process of elimination, also you can get the answer. The answer is option B. Okay. We'll move on to the next question, which is also like that only. Question number 7. Again, we have to match the pair, right? So I'm going to show you a curve. Based on that curve, you have to answer. This is one. So you have here temperature. On this axis, this is origin. On this axis, you have entropy. Okay, some quantity. Okay, and the curve is like this. Right. So let us, for example, remove this. Let me use a different color. Right. This one you can take it as a homework question. like this. And the last one is like this. Okay, so this is number 4. This is number 1. This is number 2. And this is number 3. Now what you have in list 1. Option 7. List 1 and list 2. So here you have curve 1, curve 2, curve 3, and curve 4. Okay. Here you have list 2. Here you have 1 saturated liquid line. This is saturated vapor line. This is constant pressure line. And this is constant volume line. Right? And the options for these are A is 2, B is 1, C is 4, D is 3. Option B is A is 2, B is 1, C is 3, D is 4. Option C, A is 1, B is 2, C is 3, D is 4. And option D, A is 1, B is 2, C is 4, D is 3. Right? So based on this, you have to check whether this point or this first curve is which of the following, second curve is which of the following, similarly third curve and fourth curve. So I'll give you a couple of minutes for you to write this down. It's an homework question which you can try, and we can discuss it in the next one. So I'll wait for a couple of minutes. I hope the question is clear to everyone. So I hope that everybody has written down the question. These are the options. You can write down the options as well.
Sir,
You
please
want?
go back.
Yes, yes. Okay. Okay.
Wha- Yes, done.
Done, okay. You can write down these options as well. Okay. We'll move on to the next question now. Question 8, I think. So question 8 and question 9 are going to be corrected, right? What we have is we have a 1 meter cube tank containing an ideal gas, right? 10 degrees centigrade and 350 kPa is connected through a well to another tank containing 3 kg of same ideal gas. Right? 35 degrees centigrade and 200 kPa. Now what happens is now the valve is open. And the entire system is allowed to reach thermal equilibrium. With the surrounding. Which are at 20 degrees centigrade. What we are asked is what is the volume of the second tank. Okay. So before I give you options, please try to solve the question. Or let's make you an option again. The option is 1.65 meter cube. Option B is 2.98 meter cube. Option C is 1.89 meter cube. And option D is none of the above. First try to solve the question, then I will explain and again give a couple of minutes for you to solve. What we basically have is we have a one tank which has a volume of 1 meter cube. So we have a tank, right? It has a volume of, let's for example, V1 is 1 meter cube. It contains an ideal gas and temperature is 10 degrees centigrade and pressure is 350 kPa. Okay, now this tank is connected to some other tank where this is a valve. Okay. And initially this valve is closed. Okay, and this also contains the same ideal gas where its mass is given as 3 kg, right? 2 kg same ideal gas, it's at temperature, so for example, M2T2, and it's going to be 35 degrees centigrade, and pressure is 200 kPa. Now, so this is initial system, right? And in this present question, what we are asked is, we are asked what is the volume of this tank? What is this V2? Rest of this information is going to be useful in next question. Okay, so first we have to find what is this V2, which is very clear, right? This is an ideal gas, so what we can do is T1 V1 is equals to N1 R T1. Depending upon the R value, we can change number of moles to mass, right? So we can write M1 is equals to M1, let's say for example R dash T1, right? And we want V1 is or V1 or V2. V2 is M2 RT2. So V2 is going to be M2 RT2 by T2, right? What does this mean? V2 is going to be M2 is what? 3 kg multiplied by R value. So for this R value comes out to be, let me write it down here. All of this in here. Okay. So then V2 is nothing but M2, which is 3 kg multiplied by 0.287 kilopascal meter cube by Kelvin into kg. Okay. Multiplied by T2, which is nothing but 35 plus 273. 273 plus 35 divided by 200 kilopascal. Therefore, V2 comes out to be 1.65 meter cube. Okay. Because here you see kg is going to get cancelled with kg. This is going to be Kelvin. Kelvin is going to get cancelled with Kelvin. kPa is going to be cancelled with kPa. So what we are left is meter cube. Anybody has any doubt?
No.
I'll give you a couple of minutes. Okay. Now we'll then move on to the next question. Okay. The next question is question number 10, I think. Question number 9. Okay, this is question number 8 and 9 are going to be connected. So from the data in question 8, determine the final equilibrium pressure. Final equilibrium pressure of the gas. Okay, so what we have is, this was our initial system. Okay, this was our initial system. What we have is final. What is the final? Now the valve is open. Now this valve is going to get opened, and the entire system is allowed to reach thermal equilibrium, right? With the surrounding, which is at 20 degrees centigrade. And what we are asked to find is now what is the volume. Then we are asked to find what is the pressure of the gas, right? Let me draw a final system. The final system is going to be like this. Right? The valve is going to get open like this. Okay, so valve is open. This is an ideal gas. This is also an ideal gas with volume. V1 is 1 meter cube, and V2, which we calculated, 1.65 meter cube, and T2 is going to be 20 degrees centigrade. Similarly, temperature is going to be 20 degrees centigrade. What is the pressure? So entire system is going to be at one single pressure, right? So we are asked to find that pressure. This is a bit calculative part, so I'll give you a couple of minutes to solve it. Options I have to give. So the options are option A, 264 kPa. Option B is 322.62 kPa. Option C is 300.41 kPa, and option D is 250.32 kPa. Okay. So based on this, can you find the answer? So anybody got answer? So anybody able to get the answer?
What is the initial pressure?
What is initial pressure? So initial pressure is of the first tank is 350 kilopascal, and of another this let me write. The initial pressure of this one is 350 kPa, and initial pressure of this one is 200 kPa.
Your screen do not see me.
Yes, these are not same. After equilibrium, when you open the valve, then it is going to get in equilibrium. Okay, so proceed like this. Try to find the mass of gas in this. We are already given mass of gas in this, right? So total mass is going to be m1 plus m2. We already know what is the volume of this. We calculated volume of this. Final mass is going to be v11 plus v2, right? Pressure is unknown, and temperature has been given as 20 degrees centigrade, right? So PV is equals to nRT. You don't know what is P, you know V, you know N, you know R, you know T. So you can find out P, or you can find out the value of P. So first try by proceeding. Sorry,
I cannot able to screen.
you cannot see the screen.
No.
Just wait 1 minute. I will just check. Share screen. Now can you see?
Yes, yes.
Yes. So what I was saying is, just 1 minute. What we have is in the previous question, this question we calculated what is the volume of V2, right? Right.
Right.
So what is
Right.
so when we open this valve, right? So this entire system is going to get one system, right? So what is going to be total volume of this system? it's going to be, the volume is not going to change, right? So for example, its initial volume was V1, which is 1 meter cube, and final we calculated as 1.65. So when we open the valve, the volume of the entire system is going to be V1 plus V2, right? Which is 1 plus 1.65, right? Then this is the volume, and then let's, for example, when the valve is closed, the amount of gas in this was m1 kg, right? For example, and this is m2 kg. Now, because there is no loss of mass for the entire system, where even if we open the valve, maybe some amount of mass can travel from here to here, some can travel from here to here, but the entire mass is going to remain the same, right? So in that case, mf is going to be what? m1 plus m2, right? So you know what is the final volume, you know what is the final mass, right? And you are already given what is the final temperature. So you know TF as well. And it is already given that this gas is an ideal gas. So if you, for final system, for this system, you know what is TF, which is 20 degrees centigrade. You know final mass, which is m1 plus m2, and you also know final volume, which is v1 plus v2. So now for this entire system, you apply ideal gas law, PV is equals to nRT, or PV is equals to mr dash T, right? You know m, you know temperature, you know volume. For example, it's going to be PF is equals to mfr dash TF, right? So you know TF, you know VF, you know MF. R dash is anyways a universal constant, so you can calculate PF. PF is going to be MF R dash TF divided by VF. So first proceed by calculating what is the mass of gas in this container. This you can again calculate, right? PV is equals to nRT, or PV is equals to mRT. You can do it any ways you like, right? So did you understand it?
Yes, I understood.
You understood, right? So just try to figure it out how to calculate what is the mass in this one. Okay. So if you want the R dash value, I will give you the R dash value. R dash is, so R dash is 0.287 kPa meter cube by Kelvin into kg. With this, you should be able to solve what is the volume of mass in this. Just try it once and let me know what mass you are getting. You want values, this is the question. Okay. Let me write this down. Okay. So what we get is PV is equals to mRT. This implies P is equals to mRT by V. So P1, sorry, we need M. M is equals to PV by RT. So M1 is going to be nothing, pressure 1. What is pressure 1? Pressure 1 is 350 kilopascal. Which is 350 kilopascal multiplied by volume. What is volume? Volume is 1 meter cube divided by R dash. What is the value of R dash? This one, 0.287 kPa meter cube by Kelvin into kg multiplied by temperature. What is the temperature? The temperature is 10 degrees centigrade, which is 273 plus 10. M1 comes out to be around 4.309 kg. Okay. And M2 we are already given. M2 has been given as 3 kg, right? So MF is nothing but M1 plus M2, which is 4.309 plus 3, which is 7.309 kg. VF is what? V1 plus V2. So V1 we are given as 1 meter cube. plus V2, we just calculated in first question, 1.65, right? 1.65 meter cube, 1.65 meter cube, which is 2.65 meter cube, right? So now PF and TF is already given. TF is given as how much? 20 degrees centigrade. So 273 plus 20, which is 283 Kelvin. Okay. Okay. So now PF VF is equals to MF TF, right? So PF is nothing but MF TF by VF. So PF is nothing but MF, which is 7.309. 7.309 multiplied by 0.287 multiplied by TF 283 divided by how much? Sorry, 293. This is 293. This is 20 degree, right? So this is 293 divided by 3.065, right? Which corresponds to PF is nothing but 322.618 kilopascal. Okay, this is nothing but option D, I think. Okay, so I hope the question is clear to everyone.
Yeah.
Is right? Okay, it's clear, no? Okay. Now this was the last question for our today's class. So I hope you have understood, and this session was helpful for you, and hopefully you will be able to solve the assignment problems pretty easily with this. So if you have any doubt for any questions, you can ask me. Otherwise, you can leave. So I'll wait for a couple of minutes if you have any doubts. Okay, thank you for attending this class, and I hope to see you all again in the next class as well. Anybody has any doubts? Rajiv, Akshat, you have any doubts?
No.
No, sir.
Oh, thank you for then joining. I hope to see you all again in the next class as well. Okay.
Have a
I'll
great
be-
day.
Yes, I will be closing the meeting now. Thanks.